All right, glad to see you all again, you wonderful people. Let's see what we got here going on. So today we're going to be using the vertex and axis of symmetry in quadratics and use them to graph the quadratic functions. So graphing the parabolas. What we're going to need is vertex form. So we're all familiar, hopefully, with the standard form. So standard form, which we are not using today. It's the one that says 3-5. So unit 3, we're homework 5. So it's not going to be the same one here. It's going to be this formula that we're going to need. And it's pretty different. It's pretty different from most of the other things that we've been using. And there's a couple of things that we should know. So this here is our vertex. So remember, the vertex is the turning point. So on a parabola, if it's up, the vertex is going to be at the bottom, which we call a minimum. And if the parabola is opening downwards, the vertex will be at the top. That we call that a maximum. So by looking at just this equation, we can immediately tell, pretty quickly where the vertex is. And if you're graphing using a table, that's really helpful. Now, one other thing to kind of point out is that the h value, I don't know who made this up, because like I would have made h like the up and down one. That way you could think of it like height. But yeah, week 11. Okay. All right. So h is the axis of symmetry, but it's backwards. So because of the negative here, it's actually going to be the opposite direction you think it's going to go. And there's no A, B, or C, but there is still the A actually. So there's no B and C. So A is this number out in the front. And sometimes there might not be an A value. It might just be like a negative. So if that happens, then it's treated like it's -1. And that determines the width and direction of the parabola. So remember, if A is positive, it's like a smiley face. If A is negative, then it's, well, a frowny face. Whew. So vertex form shows the vertex on the quadratic function in respect to its parent function. So parent function, now I skipped one of the lessons on this because it's kind of a big long lesson. And we're probably not going to get to all of the parts that are needed for that lesson. But to sum it up, parent function is basically the most basic function of its kind. So it's like, everything's ones and zeros pretty much. So this is like the most basic function that you can get. And to show that, I'm going to go ahead and put it on Desmos, which is a pretty good thing to use, and you can go ahead and use some of it for some of our assignments here. I'm going to go ahead and switch on over to internet. And let's go ahead and go to Desmos. Let me get my packet out in front of me. So let's start off with the parent function. So parent function is x, and I'm going to push this little keyboard button here, x squared. And there's the most basic way that you could have a parabola, a quadratic. That's again, the most basic way you can graph it. That's why we call it the parent function, because everything else is going to change just a little bit. Now I'm going to put in number 1, so that's going to be x squared plus 9. X squared plus, and as I push 9, watch what happens. Oops. Okay, you can't see it because it's up here now. Now, if I change this to any other number, so if I change it to 8, it's going to go down. If I change it to 7, it's going to go further down. But that number, the last number, determines whether or not it's going to be a top number or a bottom number. whether the graph goes up or down, the parabola, I should say. And if I were to change this into a slider, which actually I would need C. C so now I can change the value of C right before your eyes. So if it was 0, it's going to overlap with the parent function. And as I raise it, it's going to go upwards. Now the shape is not changing. It's easy to look at that and think, okay, well, it's getting, wider or narrower, but it really isn't. Now that I put it at 9, it's back to where it was before. So you can see where it changed. And again, there are these are what we call transformations. And there are 4 of them. There is, let's see, first one, we call it a shift, is what we're going to call it today. The first one is a shift. The next one is going to be a reflection. Reflection. And then these next 2 are actually going to be the same one. So if you change your A value, you can have a compression, or you could have a stretch. And again, those 2 are the last ones. You also have rotation, and dilation would be kind of one of these 2 here. But for today, these are the only ones we're going to need to know. So when we looked at the graph, we can see that this one here is going to be a shift up of 9. And that's the only thing that's happening with that first one. So let's go ahead and move on to number 2. So I got x squared minus 2. Switch back over here, shift. And we're going to change this to -2. Luckily, I have a slider, so I'm just going to move this down to -2. There we go. Yep, just a shift down 2. Again, the shape didn't change. I know just because they're both a little curved, it's easy to look at one and think it's getting wider or not, but that's just an illusion. It's just your eyeballs lying to you. Okay, you shouldn't trust everything you see anyway. But now we can see what's happening to the figure. I'm going to switch back to the work, and this is going to be a shift down 2. So the graph just moved down 2. All right, now let's do some more that are a little bit more complicated. And again, for these, go ahead and just use Desmos for all of these. So it might be a little bit easier. I guess you could graph them by hand, but that would take a while. All right, so what we can tell about this graph, so that A value is negative, so that means this graph is going to open downwards. And watch what happens to this 5. Now, this is also the shift sideways movement. So think about that. Which way is it going to shift? And think about that. It's going to shift which way. So I'm going to go ahead and put this into, oops. Let's see. And we'll call this one H. And I'm going to go ahead and add K to it. And I'm going to make this one A. So there you go. Oops, K. Add slider K. And this just allows us to change a couple of these things. That way we can see it. So first thing I want to do is let's go ahead and label our new graph. So let's just punch it in like this. And this is just a way for you to kind of see it a little bit easier. X plus 5. And then I'm going to need to square it. And you can see it's opening downwards. In fact, actually, we already have the whole thing graphed. So we need to make this red line look like the green line. So as I change this one, watch what happens when I change it. So it's getting wider, wider, wider. And then as soon as I cross it into the negative, it's going to go downwards now. And when I turn it into -1, it's going to match this here. So it's been reflected. Now, as I move H, remember, that's the one that moves the sideways ones. So if I make it negative, which way do you think it's going to go? Well, let's see. If I move it to the negative direction, so if I move it to -5. Yeah, it is going to go sideways. Wait a minute.
Oh, it's going up?
No, that's not right. That's not right. That's not right. Why is it doing that? Yeah. Oh shoot! I know why. Because I didn't put the square when I changed the square. I didn't put it back where it should be. The square should be on the outside. Okay. Now as I move it, if I move it towards the positive, you notice it's going the opposite way. Yeah. And if I move it towards the negative, now it's going to go towards the positive direction. So this one's backwards from the way you would think it would work. But the K, if I want to move it up, I can make it positive, make it go up and down as negative. So at least that one makes sense. So now I got them to match. And I just use these numbers as my A, H, and K. So at least we can see what happened from the green line from the blue line to the green line. We can see that there's been a reflection, right? Because it changed the direction of the opening. And then it shifted left 5. So let's go ahead and put that back here. And again, we call that a reflection. X-axis. Oops. I said X-axis, not A-axis. Because you can have reflections about the Y-axis. And then we also had a shift left of 5. All right, now let's go ahead and move on to number 4. All right, so we have x minus 4 squared minus 1. Well, actually, that would be the difference of x and 4 squared. So I'm going to reset this. I'm going to reset this to where it used to be. And change that back to 1. And then h is going to go right there. So now it's back to where it was. Now let's punch in our new one, which was x minus 4 minus 1. And we actually don't need this thing here, so I'm going to move it, get rid of that. So now we need to make this blue line move over to the other side. So if I change the A, which actually this one does not have an A value, so actually I wouldn't need to change our A value. So let's mess around with our K a little bit. So move it around. All right, so it's gone down. So we could say a shift down. And then move, and again, I'm gonna move it the opposite direction. Moves to the right 4. All right, that one was actually kind of easy. Okay, so let's go ahead and move on to number 5. So let's see what happens, because in this case we have 1/3 in the x squared, and actually this one does not have the parentheses. So let's see how that affects things. But with this one here, we could probably tell what's going to happen, and that is it's going to move the entire graph upwards. All right, so let's go ahead and go on over to the screen and let's punch that in. So it was 1/3 x squared, and I'm just going to type it in as I saw it, plus 2. And I'm going to get rid of this red one for now. So I'm just going to reset all of the things back to the original. There you go. Now it's not distracting anymore. So how did the blue line become the green line? Well, for one thing, it's moved upwards. So we had to move it up just a little bit. So we shifted it up. And then from there, it kind of opened up a little bit. It became what's called compressed. So with stretch and compression, so stretch is kind of like you're grabbing it and you're just pulling it like that. So if you had like, if you had drawn it on a piece of stretchy fabric, you know, and you stretch it, it's going to cause it to become narrow. And the green line here is compressed because you imagine it getting squished. So if you squish something, I don't think I have anything that's nearby that I can squish. But if you squish something like a clay dough, a block of clay, it's going to, you know, get wider. So now we know what's going on with this one here. So compression and shift up 2. And don't worry about the, well, with the numbers and all that stuff. With the numbers, it's just telling us exactly like how much it would have compressed. So basically each number is like 1/3 of the number it needs to be. All right, but I know that's kind of a tough thing to understand sometimes. So I'm gonna just leave, we'll just leave it at compression. Now let's go ahead and go on to the last one. So -2 times the sum of x and 4 squared. All right, let's go ahead and punch that into our graph. So I'm going to put it into this one here. And let's see, -2, and then x plus 4 squared. All right, so now again, we need to figure out how did this blue line become the green line? So messing with A first. Nope, not that way. Let's try to get the shape to be roughly the same. And that kind of makes sense because if we make -2, oops, that's -2.1, there you go. It's the same shape. Now we just got to move it sideways. And that's going to be our H value. And again, which way should I make it positive or should I make it negative? Yeah, see? Goes the opposite way that you would think. So now we've seen what happened. We reflected it and then we shifted it over. We shifted it left. But again, be careful. That H value is tricky because again, it's opposite the way you would think it would move. So reflection on the x-axis. And then we also had a stretch and then shift left 4. So those are the 3 things that happen. Okay, now we have number 7, which one this is going to be a little bit different because it says here, Mason graphed the parent function of a quadratic, which we just kind of did, you know, like that's the blue line in our graph. He then reflected the parabola over the x-axis, translated it 7 units up and 3 units to the right. What is the new equation of this parabola? All right, so let's go ahead and go back over to this thing here. Now we don't know where it is, so in fact, we don't need this green one here. And I'm gonna reset this to the the parent function. So set it back. All right, so it says, now that it's back, it says here, it reflected it over the x-axis. So to reflect it, we just make this into a negative, and we'll have to make it -1. So it's the same shape. You can see that it's symmetrical up and down. That's the same shape as this one here. And then translated it 7 units up. Oh, I should ask you guys which one it was. So there you go. Now it's been moved 7 up. And the other one, it says 3 units to the right. So which way do I need to move it? Towards the positive or towards the negative? Yeah, there you go. You guys got it. There we go. So now we just copy this part here. And to do this one, I'm just going to write it here. So we got negative negative a. It should be -1, but I'm going to just put negative. So x, and then our h value is +3, or in this case, -3, because we actually need to go opposite the way we were going. And then square it, and then +7. And now my green line is over the red line. So that's right. So we just got to copy this onto our worksheet. And I'm going to put it right here. So y equals negative x minus 3. Oops, nope. X minus 3 plus 7. And I need to close this and then put a square root right there. So there we go. So that's the formula that we need for this new parabola, the new equation. All right, so that's it for the new stuff. This next one's going to be a lot of the same stuff that we've already done. So we've already done graphing by table, and actually graphing with Vertex might actually be a little bit easier. It's a little bit more complicated, but it is a little bit shorter overall because it is kind of like a shortcut. Anytime you have a shortcut, it's not always the easiest way, but it is usually the fastest way. All right, so let's go ahead and move on to the first one. Graph using the vertex form. So give the vertex an axis of symmetry of each function or inequality and then graph it. So first thing is the vertex. So I'm going to put V for vertex. And let's go ahead and take our number. So it's going to be an ordered pair. And remember, it's opposite of this number. Since I have -2, the opposite would be +2, and then 3. And then for axis of symmetry, I'm just going to put A, which this is, the axis of symmetry is pretty much the easier one to find, because in this case, it's just x equals 2. Because remember, this is an x and a y, so just copy your x value, and that's it. So the old way we would have done this is to put -b over 2a, and that's how we would find the middle. That's how we would find the axis of symmetry. But since it's in vertex form, it's going to be much easier. We just have to look at this number right here, and then take the opposite of it. Take that number and put it in the table so that it's put it in the table so that way it's in the middle. Now I'm going to number down. So 2, 1, 0, -1. Now I'm going to also go number it up. So 2, 3, 4, 5. And then I'm just going to plug each of these numbers into the original equation so that I will get a full value of what each of these are. And again, these are inputs. So I put them into the function and then they come out. And when we say the word function in everyday speak, we talk about what something does. So the function of a toaster is to make toast. You put in bread and you get out toast. That's what function means, right? So let's go ahead and work the first one out. So x squared, first one is going to be -1 minus 2 squared plus 3. And again, I just got this and I plugged in -1 right here. So put these two together. So just remember your order of operations, same thing. Parentheses first. So whatever's inside the parenthesis, we got to do that first. So -1 and -2, put them together, you get -3. Now I have to square this. So if I square -3, that's the same as multiplying -3 times -3. Negative times negative is positive, so I get 9. And the 3 is still there, didn't go anywhere, didn't come from anywhere, so I just get 12. And anytime something goes off the graph, because my graph only goes up to 8 and as low as -8. So if it's off the graph, usually I'll just fill it in like that. So let's go ahead and move on to the next number, which in this case is 0, which I'm also going to remind you that I'm erasing it because I don't have any space to rewrite it over and over. So if you're working on this, you might want to grab an extra piece of paper. And with that extra piece of paper, you're probably gonna have to do this, like write it several times. So you'd have one for -1, another one for 0, 1, 2, 3, 4, and 5, and so on, or however many you need to do. All right, so 0 minus 2, let's get to evaluating this. -2 squared is 4, so that's 4 plus 3, which is 7. So there we go, this one will get on the graph. And now I'm gonna move on to the next one, which will be 1, and I'm only gonna erase the parts that I need to change. 1 minus 2, that would be -1. And if I square that, square -1, I get +1. And that would be 4 right here. And then 2, so I'm gonna have 2 is the next number. 2 minus 2 is 0. But now I have to square it. So 0 squared is gonna stay 0 because 0 times 0 is still 0. And then 3 right here, so do the next one with 3. And again, you just have to rewrite this every time if you're gonna be working on your own problems. 3 minus 2 is gonna be 1. And 1 squared is 1. So I still have to add 3, so that'd be 4. Oh, and don't forget, your middle number, being the axis of symmetry, is also where your numbers are going to be the same on both sides, and your points are also going to be the same on both sides. So if I want to here put an axis of symmetry, whatever happens on this side, the same thing has to happen on that side as well. So that means this next number would be 7 if we do this right. So let's put in 4. 4 minus 2. That's going to be +2. And square +2, we get 4 plus 3, which is 7. There you go. We filled out our entire table. So let's go ahead and plot these points. So -1, -12, can't do that. So 0, 7, oops, not -12. Over 1, up 4, over 1, up 4. Over 2, up 3. Over 3, up 4. And then over 4, up 7. All right, now we just got to draw the parabola. And remember, parabolas are curved. So you might be tempted to, well, what I see a lot of times happening, I'll see students do something like this, where if I have the dots, they'll draw a straight line between each one. Okay, that's not a straight line. There's going to be a slight curve to the whole thing. And there we go, that's it. So again, you're also going to notice that our vertex, remember it's at 2, 3, and 2, 3 is right there. This one has a minimum, so we don't need, well, today we don't need to worry about that. Yeah, and that's it for that one. Let's go ahead and move on to this one here. Now this one here, okay, so this -4, is it an H value or is it a K value? Yeah, it's a K value. Now, sometimes in an equation like this, you're missing one of the terms. So it should look something like this, but it's missing one of the pieces, which in that case, if I were to write the whole thing out, actually it would not look like that. It would look something like this. Oops, that would be a -4. Right, but that's if I wanted to write the whole thing out. Actually, in this case here, I can tell what the vertex is going to be. It's going to be 0. It's going to be 0, 4. In fact, actually, you know what? I think I should leave that on there, because we will oops, okay, never mind. I can't just move that piece. So I'll go ahead and just quickly rewrite this. There you go. So it should look something like that. So vertex is going to be 0, -4. And it should be -0, but there is no such thing as -0. No, wait. Maybe there is such a thing as 0 that is negative. No, April Fools. Oh, actually, I don't need parentheses on this one. Just got into the habit. All right. So that means that this middle area, that our y-axis is going to be our axis of symmetry. And that means 0 goes in the middle. So number down and number up. And this one should be kind of a fast one. And I'll show you why. I'm going to need this space here to work. So I'm going to have to make this go bye-bye. All right. So x squared minus 4. And I'm going to put each of these numbers in here. Now, if you have matching numbers, like in this case, I have 3 and -3. They match, but they are opposite. So if I put in 3, well, if I ask you what's 3 squared, you'd immediately say 9. And then I get 9 minus 4, which would be 5. But what if I made it -3? Would that change anything?
Yeah.
Okay, so what's -3 times -3?
No, positive 9.
Yeah, it'd still be positive 9. Yeah, right? So actually, it wouldn't change anything. Wouldn't change anything. And the same thing with 2 and -2. If I put 2 in here, well, 2 squared is 4. But if I have -2 and I square that, it would still be positive 4. A positive times a negative? Positive times positive would be positive. It would not be negative, no. You should have learned that in 4th grade when you learn your times tables. Anyway, let's go ahead and go on to -1 and +1. So if I put +1 in there, it's not going to change anything. If I make it -1, it's going to still be the same result. So 1 minus 4, either way, is going to be -3. And 0, well, there's no such thing as -0, but it is our vertex. So it would just be 0 minus 4, which would be -4. And there you go. We're done with that one. So -3, 5. And then -2, 0. Down 1, or sorry, back 1, down 3. 0, -4. Over 1, down 3. And then 2, 0. And lastly, over 3, up 5. And again, it looks symmetrical. Each of these dots, you know, they're the same distance away from our axis of symmetry. And actually, both of these numbers, so I'm gonna kind of retell you one of the graphing shortcuts, and that is the rule of odds. Rule of odds pretty much means that your numbers go by the odd numbers in the points. So if I told you to make a list of odd numbers, you'd say 1, 3, 5, and 7. Now with parabolas, it's very rare that we get to 7, so we're just gonna leave it like this. So check it out. Up 1, you go between these two dots. Then the next one is 3 to here. And then to get between the next dots, you would have to go up 5. And it's off the graph, but to get to the next one, it would be 7. So that's a quick way you can check your graph. And actually, we're gonna use that trick a few times as we go through this. So let's go ahead and try to get our graph. Go through as many of these as we can. Sometimes you got to make it go a little bit up. There you go. Okay, some of the dots are not right on the grid line, so it does look like it's not going through some of them. And I'm going to put little arrows here so that way we know it's going on forever in that direction. And that's about it. That's it for this one. So let's go ahead and get ready to do the next one. So these next ones have a few tricks and stuff to them. So all right, so let's see what we can tell about this graph before we even start. So my A value is a negative. And remember, if your A is negative, that means it's going to be going down like a frown. We also know where the vertex is. Vertex will be at -5, because again, it's going to be the opposite, but it's also going to be the same as your second one. So only the H value is opposite. The K value stays the same. So if it was negative, it'll stay negative. And then axis of symmetry, in this case here, it's going to be your X value of your vertex. So we're going to have a line at -5. So I'm going to go ahead and create an axis of symmetry. And like I said, sometimes I do it, sometimes I don't. You don't have to do it, but if it helps you, you know, why wouldn't you want to do it if it helps? Let's go ahead and move down along the line. And then we're also going to move up along the line. There you go. So now that -5 is in the middle, number up, number down. And we can mark our vertex already. So over 5, down 1. So that's our vertex. And we also know it's going to open downward. So, you know, just kind of a guess. It'll probably look something like that. Or maybe like this or something. So let's see how good our guess is. Vertex, actually, we already have it. It's -5, -1. So actually, that's a free one, kind of like bingo. You have the middle square already, already covered. Now let's go ahead and go through here and plug this in. So negative of -8 plus 5 squared minus 1. Double check it, make sure I didn't skip anything. All right. So -8 plus 5, so that's like 5 minus 8, so that'd be -3. Square -3. Now, even though a negative times a negative is a positive, so we'd get +9 from this, this negative is on the outside, so it's not affected. And again, just like order of operations, this is a multiply, this is an exponent. We do the exponent first, and this is like -1. So 9 times -1 is -9. So that makes this one negative. So again, be careful with that, because actually I know that is one of the things that students miss out a lot. And now we put that number here, and since it's off the graph, I'm just going to mirror that point over to this side. Which it's not wrong, but even if it was, it wouldn't really affect the graph. And right now, today, the graph is the most important thing to get right today. Next one is going to be -7, so that's 5 minus 7. And we get -2. -2 square that, we get 4. But again, this negative here just wants to make everything negative. Okay, just like a person who's negative, they make everyone around them also negative. All right, -4, -1, put them together because they're both negative, you get -5. Let's move on to -6. So put in -6 here. And that's going to be 5 minus 6. So we get -1. And even though -1 times -1 is +1, this negative here, again, it's just bringing everybody down. Okay. And we could verify if we could verify what we get as our vertex if we put in -5. But let's just picture it in our heads. Okay, -5 plus 5 would be 0. 0 squared is 0. -0 is 0. 0 minus 1 is -1. So we still get -1. So we can go ahead and skip that one and go to -4. 5 minus 4 is 1. Now, even if we square 1, 1 times 1 is +1. But this negative, again, just has a way of just making everything around it negative. So we get -2. Next one is -3. -3. So 5 minus 3 would be 2. 2 squared is 4. And make it negative. And we get 5. There we go. So now we have our table. And I can't graph negative and +10. So I'm going to only graph these 5 points. So back 7, down 5. And then next one here is going to be -6, -2. So back 6, down 2. We have our vertex already graphed. So -4, -2. Back 4, down 2. And then -3, -5. There you go. So now we have our parabola graphed. Let's go ahead and complete this. And it does kind of look like our initial drawing, the one we started out with. There we go. We got everything on this one. Let's go ahead and move over to this one. All right, now with this one, we cannot use the rule of odds, which actually I think in one of these next examples, I'm going to try to graph one without a table using the rule of odds. All right, so, let's go ahead and start from the beginning. Let's go with vertex. So V. And in this case, let's see, what numbers do I have in here? 4 and 3, maybe? No. We don't have a K value. There's nothing after this part here. So in this case, it would be 0. And yes, it would be +4 because it's going to be opposite of this number. And axis of symmetry will be x equals 4. All right, now if I can, I can go ahead and mark my axis of symmetry if you want to. But actually in one of the examples coming up, it's going to be a little bit confusing because you're going to be like, oh, what? Anyway. So we know that 4 is going to be the middle number. So I'm going to put 4 here and then number down. 4, 3, 2, 1. Number up 4, 5, 6, 7. And again, we have a free one. We know that the vertex is at 4, 0. We know that the graph is opening upwards, but it's also being stretched. So that 3 is a stretch. So our graph is probably going to look something like this. It's going to be very narrow, and it's going to have a vertex right there where we said it would. So let's go ahead and plug things in and see what works. Okay, just like Christmas lights, you just got to plug it in and see if it works. So 3x, and our first number is going to be 1. So 1 minus 4 squared. All right, so 1 minus 4 would be 3. We square that. 3 times 9. And it looks like we're going to get 27, which is a really big number. But that's kind of what we expected. We noticed that it's going to be really narrow. So we might actually only get like 3 of these points or so on the graph. So let's keep going with 2. So I'm going to put 2 in there now. 2 minus 4 is negative 2. Negative 2 times negative 2 will be positive 4, so we get 12. And again, this one's also going to be off the graph. So I'm just going to go ahead and fill that one in on the bottom as well. And then let's fit in 3. 3 minus 4 is negative 1. And negative 1 times negative 1 is also going to be 1. And 3 times 1 is going to be 3. Oh, and while I'm at it, since I only have to do a few of them, I'm going to just fit 5 in there anyway. 5 minus 4 is 1. 1 squared is also 1. 3 times 1 is still going to be 3, which again, that can also be a way of checking our work. So if these numbers don't match up, then we know we did something wrong. So let's go ahead and graph our points. So I can only graph these ones here. So over 3 up 3, that's our first one. Over 4 up 0. And then over 5 up 3. The rest of them are going to be off the graph. So over 6 up 12, that's going to be like, or maybe not that far. But again, we can see that this graph is being stretched quite a lot. Yeah, so it's been stretched, so that makes it really narrow. I know some people will think it's being squished sideways, which is not actually a thing. And there we go, another one down. All right, and if you got the table, you know, that's pretty much all you need, and you'll just have to plot the points and draw the graph. You know, that's something you can kind of do on yourself pretty easily. So right now we only got about 20 minutes left, so I'm gonna go ahead and move on to the next one. So here we have a piecewise graph. So piecewise graphs, and I know what I've been saying in the past when I say, look for the rule change line. So here my rule change line, and they're both at -2. So this means that once the graph reaches from -2 or reaches -2, it's going to switch. Now, what I'm going to do is I'm going to do kind of what I do. Instead of using a dashed line, what I'm going to do is I'm going to have kind of like these markers pointing to where the rule change line will be. And what that does is that it reminds me that we're going to have a different rule on this side than on this side. So we have two different kinds of functions. For x values less than -2, so that's this side, we're going to use this rule. And if it helps, we can go ahead and put it into a line function, which if that helps. Okay, some people can look at this and say, okay, well, I know what to do. We go down 6 and then follow the slope. So down 1 over 2, down 1 over 2. But you know what? We don't need to go this way because we're looking for the line. We're looking at what it does over here. So actually what I'm going to do is I'm going to reverse the fraction. So instead of -1 over 2, I'm going to put 1 over -2. So up 1, back 2, up 1, back 2, up 1, back 2, up 1, back 2. So there's the line. Now, I'm going to have to erase this side because we don't want the line on that side. We want the line on this side only because once it gets here, it's going to have to change. It's going to follow new rules. Okay, just like, I don't know, the only example I can think of is like if you're driving, in some countries, they have their cars drive on the right side of the road, you know, the right way. But then on some countries, they drive on the left side of the road. So in some countries, like if you're driving from one country to another, you might have to switch side of the road that you drive on, which would get really confusing. I'd hate to be driving down the road and then space out and be like, oh shit, I'm going down the wrong way. Oh no, that's right. Anyway, last thing we need to do is cap it off. So the rule is going to be the same as the other two inequality chapters that we did. If there is no or equal to, that means we have an open circle right there. All right, now that takes care of this first part. Now we got to get to the second part, which in this case here, it looks like we're going to have a parabola, sorry. So we know the vertex, and in this case, I'm only going to go with the vertex, is at -1. Wait, -1? No, remember, it's got to be opposite. Then -5. So over 1 down 5, and this is our vertex. Now, we could graph using the rule of odds, which in this case I am going to because I'd have to draw a whole table. So check for an A value. The A value here is 1. Now remember, if the A value is 1 or -1, you can just use the rule of odds. So up 1 over 1, up 3 over 1, up 5 over 1. Make sure I get this one right. 1, 2, 3, 4, 5. Okay. And then if I had enough room, I'd go up 7, which in this case, I don't need to. So 1, 3, 5, 4 on top, 1 on bottom. There we go. And now we have our parabola. And we didn't have to do the table. So that's kind of a good thing. That's why vertex form is kind of a faster way of doing this. Now we also have to cap it off, or in this case here, I'm going to cap it off first using this thing here. So that tells me that we need an open circle. Make a bit of an, there you go. That way you can kind of tell. And then I'm going to do my best to draw a parabola between all these points. And I'm not going to use the line tool because sometimes the line tool just doesn't, it wouldn't work in this case because in order for the line tool to work, I'd need both sides to be kind of the same. Whew. There we go. There's one more to go. Yeah, there we go. We got it. Cap it off with an arrow on the ends because it's going to go on forever. And there we go. We're done. One interesting thing about this one is, like, okay, so it doesn't really talk about the domain or range. But if we were going to talk about the domain, usually the domain is all real numbers. But in this case here, the domain does not include -2. This is not really necessary, but I just want to point it out because we don't really have a whole lot of domain. And actually, this morning I had a question is of, are all parabolas all real numbers? Well, in this case, it's a piecewise function and there's 2 holes here. So if I try to pick -2, I'm just going to fall right through both of those holes. So in this case here, yeah, we're missing a part of the domain. And again, I only said that because domain is usually all real numbers. Anyway, let's go ahead and move on to the next one. Now you could use the rule of odds with this one here, but you would need to double each number. But I don't want to go too far and make things too complicated. So in this case here, we're not going to use it because our A value is not 1 or -1. So what we're going to need to do, in this case here, well, actually this one's a bit of a tough one here because it's not in vertex form. And we could probably say it's 0,6, which actually, that probably is what it is. The vertex is 0,6. And if you're really not sure, you could use the -b/2a formula, which in this case, my b value is not 6. Be careful with that. It would be 0 because we don't have the regular x number, right? I only have 2 terms, 1 and 2. 2a, and it doesn't really matter what this bottom number is going to be because 0 divided by anything is always going to be 0. So there we go. We know for sure that the axis of symmetry is going to be right along the y-axis. It's also going to be a negative number as well. So let's go ahead and start getting ready to graph it. So I'm going to start with the rule change area, which in this case is 1. Oops. So mark out where it is. This way, if I have to draw something, I have to stop right here. And let's make a table. We're going to make our own table. So 0 in the middle, because that's our vertex, the x value, number down, and then number up. But this one's different because I don't need to know what 2 is because we don't go to that side. So in a way, we're kind of saved because we don't need all these extra numbers. So let's go ahead and plug some of these in and then see what we get out. So -2 times our first number. So our first number is going to be -3 squared plus 6. -2. And then -3 times -3 is 9 plus 6. -18, because I'm going to multiply these and I get plus 6. And that's going to be 12. Or -12. So I can't graph that one. So let's go ahead and move on to the next one. So that'd be 2. So again, I'm just going to erase this part here. Plug in -2. -2, if I square that, I get 4, which would be -8. 6 minus 8 is -2. So I have one ordered pair here. And remember, these are all ordered pairs. In this case, I'm going to make them look like ordered pairs, just because. Then I'm going to do the same thing with the -1. But in this case, I have both opposites. So I have -1 and +1. So if I put 1 here, 1 squared is going to be 1. But if I have -1, that's also going to be +1. So actually, whatever I get for these two, I'm going to have to put the same number in on both of these. So that's going to be -2 times 1, which is -2. 6 minus 2 is 4. So that means both of these are going to be 4. And again, I can look at it here, wherever, and it's going to turn out to be both the same. And that's why it's symmetrical. And for the vertex, if I know the vertex is at 0, 6, I don't have to work that problem out either. So the vertex is kind of like a free one. Is a free point. You don't have to really work for it. Or if you want to, you can plug it in. All right, you can still plug it in. Don't think you don't have to or that you can't. You would just get 0 plus 6, which is 6. So if you're not sure, you're thinking, did I need to do that? Or did I convert the formula into the right form? Okay, just work it out. Anyway, there we go. So we got all of the ones we need. So -3, -12. Okay, that's off the graph. -2, -2. -1 up 4. And then 0, 6. And then over 1 up 4. Now that falls right on my axis of symmetry. I'm sorry, my rule change line. So I know that if I put a point here, that might be the last I see of it on this side. So let's cap it off. This one has an or equal to. So I'm going to make a slightly bigger dot. And then from here, I'm going to draw the line so that it goes through my points down here. And then I'm going to draw the rest of it on this side. Okay, that's fine. And again, it stops right here. From here, I have to graph using this rule. So I'm going to start at 4. So remember, yesterday I made excellent bacon. Yesterday I made excellent breakfast. Start with breakfast, so that's 4. Up 4. So it starts here, then I have to go down 3 over 1. So down 3 over 1, down 3 over 1, down 3 over 1, down 3 over 1. And I capped it off with an open circle because I do not have an or equal to here. Connect the dots using my line tool, and I am done. And remember, all of these need to have a line that goes all the way from one side to the other. No little wimpy lines or anything like that. And I'll show you what I mean in just a minute. I'm pretty sure, because I talk about that almost every single time we have a graphing exercise. I say make sure you extend your graphing lines or parabolas all the way to one side. Anyway, so that's it for this one. This one's, I know these are kind of tough sometimes. So let's go ahead and move on to the next one. Now these ones are inequalities. These ones have the little mouth, which means there's 2 extra things we need to do. We need to find out what kind of line we use, and then we also have to shade one side of the line in, but otherwise everything else is exactly the same. There is no k value, so we assume that it's going to be 0. So the vertex is going to be -3, 0. Is that right?
Yeah.
Oh, be careful. Remember, it's always going to be the opposite of that number. All right, don't get bamboozled. So we know that the middle number is going to be 3, 0. So our vertex is going to be right here. Okay, now we need a number. Oh wait, we did need the axis of symmetry really quick. And that is x equals 3. All right, 3, 2, 1, 0, 4, 5, 6. And we can plug in numbers. But remember, I'm going to use that rule of odds that we had earlier. This one has an a value. The a value is -1, which means it's going to open downwards. And we just use the rule of odds. So 1, then 3, then 5. And then I go do the same thing back the other way. So going back 1 space each time, down 1, then down 3, then down 5. And since I don't have that many points, I'm just going to put them down here like that. So again, that's the shortcut. So just mark out what you have. So over 2, down 1. And then at 1, where is the line? So over 1, down 4. So down 4 here, down 4 there. And then 0, and that's why I marked it down here so you can see it. So that's going to be -9, -9. And if you're not sure about this, you can still just do all of them. So negative. And again, you can't use this trick on all of them. So the shortcut doesn't work on all of them. But if you can see when you can use it, then you don't have to plug it in, get the number, plug it in, get the next one over and over again. Now we have to also shade this. And I know I was talking about something earlier. I said, oh. So what I was talking about earlier was wimpy lines. Sometimes I'll get students that'll do something like this. No. All right, so if you look at the ones we had on Desmos, see these lines here go on forever, right? I can do this all day. The line doesn't just end in the middle of the screen. Goes on and on forever. I need like Cheems and Doge to show me this. Anyway, so that's the other thing. Make sure your lines go all the way around, because in this case here, we need to shade one side. All right, so when you're dealing with inequalities, there are 2 things you got to worry about. And again, that's, in this case, we're going to need a dashed line. So I'm going to draw a dashed line through as many of these points as I can. There you go. So it's going to look like a parabola, but it's going to be kind of a dashed line. And remember, the dashed line means stay away from the line. It means you cannot pick something that is on the line and get a true statement. If I were, just this is an example, if I were to pick, say, x equals 3, y equals 0, which is this point right here, I would get something like 3 is less than 3, which is false. If I pick anywhere on the line, it's going to end up being a false statement. Now, the last thing is to shade one side of the graph. So I'm going to go ahead and shade using this thing here. That mouse is going to tell me which side to shade. So since it's facing away from the y, we're going to shade away from the top. So that means the bottom. So I need to shade the bottom of the graph. And this is the solution area. Anything I pick inside is going to make a true statement. So if I say over 3 down 5, like here, if I pick that as a point, I would get some, I don't know exactly what I would get. Let's say 3 minus 3 is 0. And this would, okay, so 3 over down negative 5, so that'd be negative 8 squared, that'd be negative. Okay, but anyway, I'd get a true statement. We'll come back to that. I realize I'm running out of time here. But if I pick anywhere, that mouth is going to be open towards the bigger number. Anyway, let's hurry up and get to this last one now. So vertex of this here, vertex is going to be 1, negative 7. No, negative. Remember, again, opposite. Yeah, be careful. That's an easy thing to forget. Anyway, axis of symmetry is going to be x equals negative 1. So I'm going to put an axis of symmetry on this one. Like I said, I don't do it all the time. I just do it sometimes. Okay. Put negative 1 in the middle. And we cannot use the shortcut for this one because this one has a 4 over here. So since it has a 4 there, I'm not going to be able to use the shortcut. So we're going to have to go the long way around. Maybe. We'll see what happens. But again, we also have a free point at the vertex. So over 1, I'm sorry, back 1, down 7. And since this is a 4, our line is going to be stretched. So it's going to be stretched really close to the bottom. And it's going to look something like this. All right, but let's see what we actually get. So let's plug in these numbers and see what we get. And we might have plenty of them off of the graph, so we might not actually have to do that much work. So I'm going to replace x with my first number, which is negative 4, plus 1 squared minus 7. All right, parentheses, 1 minus 4 is negative 3. And square that, so we get 9. So 4 times 9 is 36. 36 minus 7 is 29. So that's way off the graph. All right, so I'm going to go ahead and just fill in the bottom part too. So next number is going to be negative 3. So put in negative 3. 1 minus 3 is negative 2. Square negative 2, we get 4, because that's negative 2 times negative 2. And we get 16 minus 7. 16 minus 7 is going to be 9. And that is barely off the graph. And then let's do negative 2. So put in negative 2. 1 minus 2 is negative 1. Square negative 1 and we get positive 1. So this would be 4 times 1, which is 4 minus 7. And that would be negative 3. And I'm just going to autofill the other side too, just in the interest of time. All right, so start from the middle, negative 3 up 9, which is going to be just off the graph. And I'm actually going to graph this one just because I know I'm not going to have a whole lot of points to use. -2, -3, 0, -1, -7, and then 0 down 3 over 1 up 9. And like I said, I'm going to just do my best to guess where this would be. Whew, okay, and I can't graph the 29 because that's way out of there. And I'm gonna have to make this line go a little bit lower just so it's going through more of the points that we have. Okay. And you don't need to go past here. I'm only doing that just so that the way the shape is a little bit more noticeable. Okay, now last thing we got to do is shade it. Oh, I almost forgot something. I almost forgot to see what kind of line we needed, but in this case we lucked out because we needed a solid line anyway. So anytime there's an equal or equal, then you just use a solid line. Okay, now shade it. Look at the opening of the mouth. Which way is it opening? It's opening towards the Y. So the Y is the top. So we shade the top of the graph. And both of these parabolas are shaped. Well, let's see. Kind of to help you remember, this is like the sun right here. Okay, so if I'm trying to get out of the sun on a hot day, or maybe I just don't want my skin getting sun on it, right? This is the area that's shaded. It's the bottom, because if this is like a tent or a house or something, you're shaded on the inside. But over here, this would be like the rain. So I have some clouds here. And if it's raining and there's like a valley or a cup, that thing is going to fill with water. So that's why and again, sometimes I get this inside outside stuff. So you can see both of these, the one is on the bottom, the other shaded on the top, but they're both on the inside. So inside and outside doesn't really matter. That doesn't have a whole lot of anything to do with it. All right, so that's it for this one. There's nothing else after this. Sorry. But that's okay though. There'll be more next time. Yeah, so I will see you all later. Bye-bye now. Unless you're in my class, now you have to stay here.